Here we have the infinite series of n divided by n to the fourth plus 6n squared plus 9. And we want to use the integral test to show that this series converges. So first we can factor the bottom here. So the factors are n squared plus 3, n squared plus 3, and then we can write this as n squared plus 3 squared. And so the corresponding integral will be the integral from 1 to infinity of x dividing by x squared plus 3 dx. So once again, to use the integral test, if we want to show that this infinite series converges, then we need to show that the corresponding integral converges. So here I will use the u substitution method to find this integral. So let u be x squared plus 3. So du dx will be 2x. Then the derivative 3 is just 0. And so we have du is equal to 2x times dx. And then multiply both sides by 1/2. And this is equal to x dx. And notice that the integral here can also be written as this. And so from here we have the integral of 1 over u square. Could we let u be x squared plus 3, so this would be x squared plus 3, and then so that would be u squared. And then x dx is just 1/2 du. So this is equal to 1/2 times the integral. And then 1 over u squared, we can rewrite it as u to the negative 2. Antiderivative, so add 1 to the exponent. And then dividing by negative 1. So this becomes negative 1/2. And then 1/2 times negative 1 is negative 1/2. And then u to the negative 1 is the same as 1 over u to the first, which is just u. So we end up with negative 1 over 2u. But u is x squared plus 3. And then we need to evaluate this from 1 to infinity. So the upper limit of integration. So when x is infinity, we get negative 1 dividing by infinity. Which is 0. And then this will be 1. So upper limit of integration is infinity. Lower limit of integration is 1. So here we get negative 1 divided by infinity, which is 0. And then here we get 1 squared plus 3, which is 4. And then times 2, which is 8. So we get negative 1/8. So which is equal to 1/8. And therefore this, the integral converges. So this integral here converges, and therefore the infinite series here converges by integral test.